Hello everyone, this is Manikanda from Pragati Engineering College, Surampalam, Andhra Pradesh. I am from third year ECA. I have to give oral presentation on car black box project, which I have completed during the internship provided by MRTechC. First of all, see what are the contents I have learned during this internship and what I am giving on this presentation. First of all, introduction to car black box, project requirements, C programming, embedded systems, microcontrollers and microprocessors, different peripherals which I have used in this project, and what are the tools I have used in this internship, and car black box project implementation. First of all, see introduction to this project car black box. A car black box is a device installed in some automobiles like cars and other automobiles. These car black box is record information to about vehicles during the accidents, before the accidents. It records information like speed of the car or automobile and location of the car and distance travel. Like those information it records. The information recorded can be collected after a crash and analyzed to determine health, insurance office, and etc. What are the conditions before the or during the crash or any event. Due to this car black box, we can collect the information and analyze it. By using it, we can determine the condition of this car. This car black box consists of a microcontroller, LCD, and other devices. Let us see further. First of all, we have see what are the requirements for this project. For this project, we have to gain some knowledge in embedded C, that is in our C programming. We need to know some knowledge on this one, and we have to know about MPLAB XIDE and X8 compiler, PiximLab. These are the softwares which are used in this project. And PIC 16F877A is a microcontroller which we are used in this project. And I used different peripherals in this project. Those are CLCD display, matrix keyboard, timers, and digital switches. In this project, on this microcontroller, I created some screens for this project. Those screens are default screen, login screen, main menu, view log, set time, and event capture. Let us see further. First of all, when we are discussing about this project, we have to know about C programming. We have a question, that is why we are using C programming. That means we have some reasons why we are using embedded systems, why we are using C programming. The reasons are processor independent and portability. Processor independent means if you write a program for a processor, for another processor also you can use this program by modifying small things. You can use the same program for another processor also. We have other advantages, that is portability and C high performance. In C programming we have another advantage, that is bit manipulation. In C programming we can do bit manipulation very easily, and memory management in C programming is very good. In this internship, before this internship, I know C language basics only, but during this internship I have learned different concepts of C language. Those are data types, conditional constructs, means, for loop, while loop, and other statements, and operators, different operators, arithmetic, logical, and other operators also. I have also learned about arrays, pointers concept, functions, recursion, string, storage class, and preprocessors. We use some of these concepts in the project. And then, what is an embedded system? An embedded system is a combination of computer hardware and software designed for a specific task. That means we use embedded systems for a specific task only. In this embedded system, we have to combine hardware and software also. Embedded systems may have a lot of examples like air conditioners, washing machines, etc. We have wide applications in different industries and agriculture and automobiles and household purposes. Those embedded systems are of different types. This we have these 5 types of embedded systems. First one is standalone embedded system. In standalone embedded system, we have 2 types of standalone embedded systems. That is slave standalone embedded system. The example for this one is in semi-automated washing machine, and we have another type in this one, that is independent embedded system. Example for this one is a Google car, and second one is the real-time embedded system. These means these embedded systems operated based on the time. They have to respond based upon the time. For this examples are airbag system. We all know about the airbag system in a car and a pacemaker. The third one is a networked embedded system. Example for this one is a router. We have another 2 types: mobile embedded system and a hybrid embedded system. These are the types of the embedded systems. And the differences between the microcontroller and the microprocessor. We use microcontroller as in heart of the computer system, and microcontroller as in heart of embedded systems. We use microprocessors in personal computers and other equipments. We use microcontrollers in maximum of embedded systems like washing machines, air conditioners, etc. In microprocessor, all components are assembled separately. That means the components in this one are not assembled on single chip. These are separate. We have to connect each other. But whereas in microcontrollers, all the components are on single chip. That means all are integrated on a single chip. That means timers, memory, and etc. other peripherals are connected on a single chip. Because of this, microprocessor is more flexible because all components are separated. But as in microcontroller is not more flexible because all are integrated on a single chip. By this, you can say microcontroller has a less design complexity because all are connected in a single chip. But as in microprocessor, we have more design complexity. We use microcontrollers in our embedded systems. This PIC 16F977A, it's a microcontroller board from Microchip. This is an 8-bit microcontroller. I use this microcontroller in my project. Let us see this microcontroller board. This is the PIC 16F877A microcontroller board. This board this is the microcontroller IC. This is a PIC 16F877A. This is the microcontroller board. This microcontroller consists of 5 ports, namely A, B, C, D, E. A is in 6-bit, B is 8-bit. We use these 8 bits as in bidirectional pins, and port C is also an 8-bit. We use these pins as in digital pins for serial communication, and port D also is in an 8-bit. We use this as a digital pins, and port E is a 3-bit. We use these ports based upon our application and our uses. We use this one. With this with this microcontroller we cannot do this project. We need to use some other peripherals also. These peripherals are matrix keyboard, timer, ADC and CLCD. We use these peripherals in this project. Matrix keyboard is used to give inputs in the form of numbers, alphabets. That means we apply input by using this keyboard to the microcontroller, and microcontroller process this information further. And then timer is a very important peripheral for any embedded system. Maximum of all embedded systems has timers. We use these timers for maintaining the timing of operations and for controlling the blinking rate of LEDs, or controlling the sample rating of ADCs, or a sample delay on the source code. We use timers maximum in all operations for timing controlling. And we use an ADC, which is analog to digital converter, which is an electronic device which used to convert an analog signal into digital form. We know all the signals in our environment is analog. We need to convert into digital form. You need to use ADC. And we use another peripheral CLCD, which means character liquid crystal display. It is used as an output device which is displays the ASCII characters and other some special characters. It shows the output to us. And then discuss about which are the tools or software which I am used in this project. Those tools are PixSimLab and MPLab XIDE. PixSimLab is a real-time emulator of developing boards. PixSimLab is used. Let us see the software. This is the PixSimLab software which I used for this project. In this PixSimLab, we have different types of boards. We need to select any board which we want, and we have to select any microcontroller which we want to do a project. PixSimLab is a software which gives the virtual boards for us. In PixSimLab is integrated with an MPLab X debugger. In PixSimLab, we don't have any option to dump the direct program into the microcontroller. We can't edit the program or source code in PixSimLab. For editing and debugging the code, we need to use MPLab XIDE software. See this software. This is the MPLab XIDE software. What's the purpose of the software means? What is the code we need to write this code in this software, and this software converts the C language code into an hexa file, and that hexa file is loaded into the microcontroller board by using that PixSimLab. This is the code which I have written for this project, and we have converted this code into an hexa file, and that hexa file is loaded into the microcontroller board. By using these two softwares, I completed this project. And when coming to this car black box explanation, let us implement this project in PixSimLab software. This is the PixSimLab software. On this, first we have to reset this board by pressing this switch. We resetted the board. When initialize, this board is on default screen. On this default screen, we have seen these three, that is time, and E means engine status, and SP means speed of the car. This time is connected to the real-time clock. Based upon our real-time clock, it shows the time in this one, and engine status is in on status. We can change the engine status by using these three switches, and we can change the speed of the car by using this potentiometer. First of all, change this engine. We use this switch 1, 2, 3. We use this switch for clash purpose. When we press this switch, engine status is changed to C, that means clash. When any car clash, then switch is pressed and engine status is changed to clash. And then we use these two for changing the gears of the car. This gear is for up gear. When we press this one is normal, gear is in neutral, and when again I press this switch 1, the engine status will change to reverse mode. For gear 1 I pressed this one. Now engine is in gear 1 mode. I change the speed to 23 kilometers, and then for gear 2 again I need to press this switch and this engine is changed. I increase the speed by rotating this potentiometer, and now speed is 46 kilometers. And now again I press this switch and this gear is changed to 3. Now the speed is changed to 62, and fourth gear we have to press this switch again. On this switch is 88. Maximum speed of this one is 99. For down gears we need to use this switch. By pressing this switch, gear is changed and we can reduce the speed. These all our events are stored in this memory of this microcontroller. For seeing these events, we have a security purpose. That means we have to enter our password to see what are the events occur. So for that purpose, we need these two switches to enter the password. To enter the password, we have to press any these switches, any one of the switch. Press this switch. This asks for our password. I need to enter the password. I am entering the password. I enter the password. It shows the option view log and clear log, and we have another option. First of all, this is the view log mode. In this, it shows the 0 event. On that event, the time of the event occurred, and engine status and speed of that event. For next one, I press this switch 1. For that event 1 and the occurring time and status of the engine, that is in class mode with the speed of 60. And again for next event, I press this switch on in this neutral mode, speed of 60, time is 1938. And further we have to check all the events which are occurred. In gear 3 we have speed of 46, and in gear 4 the speed is of 62, and in gear 4 we change the speed to 99. These are all the events occurred in this one. For going back, we don't have insufficient switches on this one. For that we have any option to go back. For going back we have to reset. So I enter reset. Now do some events. I change the gear position to 1, speed to 33, and gear 2 with the speed of 53. Now some events are occur. For login mode, I press the switch and I entering the password. I log in now. For clearing this log, I have to go down. I have two options, clear log and change password. For clear log, I have to enter. So this is the enter, and all logs are cleared successfully. So all logs are clear. Now I want to change the password of this board. I have to enter. It asks for the new password which I want to set. So I am entering some new password. I enter the new password. It asks to re-enter the new password. I re-entering the new password. So it shows password change successfully. I changed the password. Now I reset it. Now I entering the password. I enter the wrong password. When I enter the wrong password, it shows I entered wrong password. I have only 2 attempts to enter the. I again entering wrong password. It shows I have only 1 attempt to remain. And again I entering wrong password. It shows you are blocked. Wait for 57 seconds to. When I enter the wrong password, it shows this notification. This is the project which I have been completed during this internship provided by MRTechC. Thanks to MRTechC for giving me this opportunity and providing this internship to me. Thank you all for watching this video.